Good morning. Today we are actually going to put two lessons into one video. So we're going to talk about both 3.4 and 3.5 at the same time. They're pretty interconnected, and I think it's going to help in having them together. So lesson 3.4 is all about the movement of water on the surface actually. So we're going to talk about rivers, components of rivers, and how that water is going to come all together. So a river can even be formed based on the water cycle, which we talked about already. So by runoff, we can create and dig in rivers by erosion. Rivers are always going to start at one place. That's called the headwaters. So the head is the beginning of our river. As that river flows down, it's going to have other rivers attached to it. They're called tributaries, except they're much, much, much smaller. So tributaries are small streams or sources of running water that lead into and feed into the bigger river that we have. Now at some point, if that river exits into the ocean or into a pond, lake, something like that, we're going to see that it exits at the mouth. So the mouth of the river is where it ends, where it opens up and it spreads, spits out all of its water into another body. But there's also other contributing pieces that will go into that body of water. And one of them is going to be caused by runoff in the movement of a watershed. And a watershed is any type of land, piece of land, that will actually contribute water to a river or a body of water. So because it has runoff going down at steep grade here, we see that we're going to have an increase in the water here in our lake area. Now, an important note about how this water moves is based on the gradient. So the gradient is the angle that our land is going to follow. So if we have a steeper gradient, that means the land or the water is going to flow much faster. So a waterfall has perfectly perpendicular. Other rivers are going to have more or less steep, which will help them move more or less quickly, and that angle or gradient can change over time. Now, our entire river, despite where the headwaters are and despite where the mouth is, are going to follow what we call the channel. So the channel is actually the pathway, the cutout mapped part of the river, and the path that it follows, which will become very important as we talk about, okay, well, how is the water getting here? How is it moving around? Which was important for the activity you did that talked about the movement of water in Sampson County here. But that activity also talked about different types of pollution, and the main two that we're going to focus on are point source pollution and non-point source pollution. So for point source pollution, you can point at the source of where the pollution is coming from. So if we said it's coming from a tributary, we know that we had runoff from a chemical plant here, and our pollution in the lake was caused by this source. We know exactly where it's coming from, either the location, the building, or the cause. Now, on the other hand, you can imagine non-point source means that we don't know where it's coming from. We see that there is pollution, we see that it is present, but we cannot find the origin or the location. Now, in modern days, we find that point source pollution has been prevented much better, prevented and regulated, but non-point source pollution is actually the real problem, the real kicker, the mystery, the solving, and that's what we're trying to eliminate. When we look at these areas of pollution, we're going to notice changes in pH, so how acidic or how basic our water is going to be, and that can be greatly affected by things like metals and salts, acids and bases. So those things are going to react with water and change its composition. Turbidity, we talked about the first day, so how clear is the water? We notice that when water is chalky, when it picks up bluish, reddish, or greenish tint, that there's something else in there causing those. For instance, really rusty water from mining is often going to be looked at as very orange, red, bronze, but water that's extremely high in things like chlorine could end up being more of a green, blue tint. This all comes back to that universal idea of water being solvent for everything. That day that we introduced the unit, we talked about how water was taking up different amounts of salts, and it was acting as the universal solvent, that it was soaking up all of these different compounds and chemicals. When we look at the whole spectrum of things here, we see that pollution can travel down these paths from a variety of places. So when we talked about the underground water system, it's enhanced by this water system as well. So the runoff could be polluted, the tributaries could be polluted, the headwaters could be the source. A plant in the mountains could be a source. So knowing the channel, we can trace back and track where that pollution is coming from. Either way, we're still focusing on where the water is, how did it get there, and why is it doing what it's doing.